Good morning, everybody. Today, today actually I am going to start the communication. So communication specifically it is related to optical communication. So first of all, what do we understand by communication? We have to understand first. Then we have to understand the communication system. Then we have to understand various component that associate with the communication system. Okay, first of all, what do you understand by communication? Communication means the transfer of information from one point to source to destiny. Suppose I want to send information, suppose from my home and to your home. This is communication. Communication refer the transfer of signal or information from one point source, that is in my house, and to the destiny. Suppose I want to send information from my house to your house. This is transfer of information from one source, one point, the source. One point means initial point, that is referred to as a source, and to the destiny I means your home. This is known as a communication. Okay, and the system that responsible for transfer of information from the source to destiny is known as a system. Okay, system, I am again telling the system is responsible for transfer of information from one point to another part. This system composed of various components: electronic component, electrical component, medium also. Okay, that's what we are going to discuss. Okay. So first of all, I am focusing on the system, communication system. So communication system, first you have understand the communication and system. Okay. Second is the electromagnetic spectrum. Why this is important? So in communication we are encounter electromagnetic spectrum. I'm going to tell you the optical communication. Optical is nothing, electromagnetic waves. Okay. Whenever we encounter optical communication, we have to know the communications first. Communication, then system. I have already told the system is composed of various electronic components and for different functioning. For example, I am going to show you what are the components in communication system. The system is responsible for transfer of information from source to destiny. Okay, then electromagnetic spectrum. What do you mean by electromagnetic spectrum? Why it is encountered in optical communication? Because in optical communication, or whatever the type of signal in the input, we will transfer the signal to electrical form, optical form, and this optical means electromagnetic spectrum. So we have to know the electromagnetic spectrum. Now what do we mean by electromagnetic spectrum? Okay, and how electromagnetic wave is generated, electromagnetic radiation is generated. Such particle, whenever it's moving at a constant velocity, like Bohr's theory, it neither absorb or nor emit energy. Okay, whenever such particle start accelerating, okay, then such particle give the radiation. Okay, this radiation, that is electromagnetic spectrum, and we have to understand. First of all, electromagnetic spectrum is a combination of frequency band of different electromagnetic waves. See, electromagnetic wave fall in different frequency band. Frequency band means it is a range of specific frequency, and band of electromagnetic spectrum is a combination of different frequency band, just layer by layer. Okay, that's what we are going to study. So you have already understood this part. I am erasing this part. Now what is the electromagnetic spectrum? Okay, whenever we encounter electromagnetic spectrum, always remember this formula that is not available in a book. I abbreviated so that I can easily remember. Okay, RMI I UVX gamma C. This is code I nomenclature as to remember. This is increasing order of frequency. Always remember. This is not available in a book like that. So only to remember the electromagnetic spectrum, I abbreviated the whole electromagnetic spectrum is like that. R stand for radio wave. Okay, And M stand for microwave, I stand for infrared, UV visible, UV and visible, UV and visible. X-ray is X-ray, you have already studied. Gamma stand for gamma ray, for an atom get transformed to another form of atom in nuclear physics, particle physics, you have already studied. And C for cosmic ray. Cosmic ray is related to high energy physics. Okay, we are mainly focused on RMI, UVX up to X. Gamma ray and cosmic ray, we are not going to study here. This part is related to the high energy physics. Okay, high energy or nuclear physics. So, and remember, this is increasing order of frequency, increasing order of frequency, increasing order of frequency. How can you remember? It is very easy. R stand for radio wave, and always remember this spectrum is essential everywhere. Whenever you study quantum mechanics, it is also essential. Whenever you study atomic physics, also necessary. Spectroscopy and different particle physics, nuclear physics, everywhere, radiation spectrum. Okay, R stand for radio frequency region, T into, very easy to remember, T into 6 into T into 10 to the power 10 hertz. Okay, remember. Then M stand for microwave, is very easy. This part is going to T into 10 to the power 10 to, only T is common, okay, 12 hertz, T is common, 10, 12. First one is 6 to 10 means it is 4 difference, and then 10 to 12, then 12 to 14, then 14 to 16, then 16 to 18. And I represent infrared frequency. It is comes to this T into 10 to the power 12 to T into 10 to the power 14 hertz. Okay. Similarly, UV visible as same time, UV and visible T into 10 to the power 14 to T into 10 to the power 16 hertz. Okay. Then next X-ray is T into 10 to the power, this is comes here 10 to the power 16 to T into 10 to the power 18 hertz. This way goes like that up to 22. Okay, and this is available, this spectrum is already given. Okay, CN Benuel book, section number 1.3, page 6. This spectrum is already given in spectroscopy book, CN Benuel, section number 1.3 and page number 6. Okay, but this code is I abbreviated so that we can easily remember. RMI, UVX, gamma C, increasing order of frequency, and reverse is increasing order of frequency means decreasing order of wavelength. Okay, this part, high frequency region, is very toxic to the human body. Okay, a low frequency region is less toxic as compared to this part. Microwave, that is microwave oven we are using, that is microwave, still it is harmful to the human body. That is why we never advise to open the microwave when it is switched on. Okay, this is the electromagnetic spectrum. Next the radio frequency, optical frequency, radio frequency, that is I have already told you, radio frequency, the optical communication. After development of different optical communication technique, advanced communication technique, this optical communication carrier frequency, optical radio frequency region, optical communication operate in the radio frequency region. Radio frequency, that's I have told you, T into 10 to the 6 to 10 to the 10. And optical frequency range 10 to the 13 hertz to 10 to the 16 hertz. Okay, this is how we operated. Why this optical frequency necessary? That is why you have to understand basic diagram of communication system. Basic diagram of communication system. You see carefully, then you can easily understand. Information source, then transmitter. This is a basic block diagram of communication. Transmitter, modulation is also there, then communication channel, then receiver, demodulation, modulation, and destiny. Destiny means to where we want to send. This is the basic block diagram associated with the general communication system. First one is it is may not be visible, but I am telling you this is the information source. So information source, what happened? Information source is information from the source is sent to the transmitter. Okay, in the transmitter there is a modulation is also there. Why modulation is important, I am telling you. Okay, after finishing this part. Then communication channel. Communication channel means medium. Medium means through which we are going to send the information. It may be optical. This is a pipe. Okay, I want to send information from here. This, and then I will extract the information here. This pipe will act as a medium, or it is known as a channel. Okay, and receiver will receive the signal, and demodulation receive the signal, extracting the noise, and it will send to the destiny. This is general communication channel. Okay, this, what do we understand? We have to focus mainly from transmitter, receiver, and channel. These are the important part. Channel means it is optical fiber, coaxial cable, coaxial cable, different type of cable, the copper cable. Okay, copper cable you have seen, that is a channel. Suppose this wire is connected with a fan, so when you on the switch, the signal is coming from that source switch, suppose switch to fan. This is the destiny. That's the through which the signal, electrical signal comes, that is known as a channel. Okay, channel means it may be optical fiber, it may be free space, it may be coaxial cable, it may be copper wire. So these are known as a channel or medium. Okay, clear? Now, second point, information source. What type of signal it is? Suppose I am telling you this is a sound signal. Sound signal is non-electrical. So how can you send this transmitter? This transmitter composed of electrical component as well as electronic component. Okay, and why I am writing here modulation? Modulation, I am telling you. This, suppose I am sending a slow voice message. This is a non-electrical signal. So in that case, there is a transducer is there. Then what transducer or sensor will put it here. Okay, that transducer will convert the non-electrical signal to electrical signal. Okay, then electrical signal comes to here. Okay, if the signal frequency, suppose I am giving one example. If the signal, now converted signal is electrical signal frequency 20 Hertz. This is the frequency of signal. But this signal frequency we cannot transport to long distance communication. Suppose I want to send a signal, voice signal. Okay, voice signal is first, it was voice signal, then using transducer I converted to electrical signal. An electrical signal, I calculate the frequency of electrical signal, it is found at 200 Hz. But this communication channel unable to send the signal of this type of frequency. Suppose this communication channel active in, suppose 10 to the power 13 to 10 to the power 16 Hertz frequency, operating frequency. What do you understand? This channel can transmit it. Active means this channel can transmit any signal of frequency falling in that range. Okay, that means this channel cannot transmit the signal of 20 Hertz. Then what will you do? The modulation means it will this transmitter will generate an electrical signal or electromagnetic carrier. Okay, this is, suppose if I represent, this is X original signal. This transmitter, this is original signal from this information source. Okay, this transmitter will generate a carrier frequency. Carrier frequency, suppose 1. This is a carrier frequency. Then I will modulate it the same. Modulated means mixing. Okay, mix is a mixing signal. Mixing signal into YS into X. Okay, now I will mix the signal. This is the original signal, this is the carrier signal. And now mix the signal, it will, and calculate the frequency. Calculate the frequency, suppose 10 to the power 15 hertz. Okay. Now what happened? See, this modulated signal. Modulation means mixing the original signal with carrier signal. Okay. After mixing the signal with modulated signal, I calculate the frequency, and which is found to be 10 to the power 15 hertz. Now it is fall in this active range. Active range means this channel can transmit this signal. Okay, you understand probably. Now what happened? This channel can transmit the signal. Why it can transmit the signal? Because this modulated signal, mixing signal, frequency is 10 to the power 5 hertz, and active channel is 10 to the power 13 to 10 to the power 16 hertz. So medium channel, which is often known as a channel can transmit the signal. But at the output, the receiver will receive the modulated transmitted signal, modulated and transmitted. Okay, it will receive the signal. Then demodulation is there. Demodulation means, what is our aim? We don't need the carrier signal. Carrier signal is known signal, is a fix. Okay, we want to separate a filter, which is known as a filter. Suppose in water filter, we give the water. What we are doing? We want to extract the original water, removing the noise. Similarly here, receiver will receive the signal first. Then what happens? Demodulation. Demodulation is a process of removing the carrier signal from the original signal. It will extract the original signal using the demodulation process and then transmit to the receiver. This is how we are getting the output signal. Okay. Now, during communication channel or this whole system, during transformation of whole signal from source to receiver, there is a loss of signal information. Whatever it is, if it is digital, there will be loss. If it is analog, there will be loss. Okay, and this loss mainly occur this communication channel. This loss mainly occur communication channel and interference loss. Okay, that's what we are going to study. But okay, this is the general communication system. This is I think you have understood, and this is the general communication system. And optical communication system, what actually optical communication system is there? Optical communication, you see carefully. Information source, then transmitter, okay, then optical source, then fiber optics, fiber of cable, then optical detector, then electrical receiver, then destiny. Okay, then destiny. The previous one is the general communication system. Now in optical communication, this is information. This information source means it is the signal. It may be non-electrical signal. And first of all, using transducer, if we put the transducer here, then transducer will transform the non-electrical signal to electrical signal, and then it will send to the electrical transmitter. This electrical transmitter, okay, transmitter will drive a optical source. Now what happened? This in transmitter, what you encounter optical communication, this is a non-electrical signal. Then in this system, that non-electrical, using transducer, non-electrical signal is converted to electrical signal. It will transform to the transmitter. Now this whole system is optical communication system. Transmitter will drive a optical source. Okay. Second, this transmitter composed of optical conversion. Optical conversion will also take place in transmitter. Optical conversion means electrical signal converted in optical output. Okay. Suppose LED. LED is what? When you give a current, so it will give a light. So electrical converted to optical. Okay. This optical conversion will take place here, and this optical source, it will create an optical carrier frequency, carrier signal. The carrier signal will mix with the original signal and then send to the fiber. Okay. Fiber cable. This is a cable. Cable means channel. Then it is a now, so this original, now this input signal to the optical fiber is a optical signal. So there will be optical coupler is also put it here. Optical coupler, why put? Because we cannot randomly send the light like this. We have to send the signal at a specific angle inside the cable, so that total internal reflection take place, so that it will see. I will tell you detail in later. This is a fiber cable. Okay, and this signal is come from here. This is the axis. We will send the signal at a specific angle, so that it will total internal reflection take place. Okay, and there, that is why in between optical source and optical fiber we put a optical optocoupler. Optocoupler is a micro lens. You can say the micro lens. We will put a micro lens. Then total internal reflection is take place like that. Information will send to the optical detector. Optical detector means it will detect the optical signal. Okay. And what is the optical source? Laser diode, LED diode, semiconductor laser. This is the optical source. And optical detector, PN diode, avalanche diode, it will detect the optical signal and convert it to optical signal to electrical signal. Then electrical receiver receive the signal and demodulated the signal, and finally send to the signal to the destination. This is the mechanism that we have to understand for optical communication, and which is similar to the general communication system. Okay. Now, what are the important part we have to study in this course? Our main part, optical transmitter. Transmitter is composed of electrical component as well as electronic component. Okay. Then this transmitter will first receive the signal from source and convert the signal to the optical form. We receive the optical signal. Okay. Electrical signal. And then transmitter will convert electrical signal to optical signal. Then it will mix with the optical carrier frequency, electromagnetic wave. Then it will send to the fiber cable. Okay. Total internal reflection inside the cable take place, and finally optical detector is a electronic device that will detect the signals. Then optical detector detect the optical output signal, and it convert to the electrical signal. Electrical signal transmitted to the electrical receiver, and in electrical receiver it receive the signal and separate the signal from the carrier signal. Okay, and this is sent to the destination. This is the whole mechanism, and we have to study. Transmitter already developed. Semiconductor laser, LED diode is also conversion process take place, and optical source. We know main point is optical fiber optics communications, and optical detector already developed. We are going to use only. Okay, we are not going to develop the optical detector, optical source. Optical source means laser light, LED, and optical detector, PN diode, avalanche diode. Sometimes photodiode is also used. Okay, we are not going to focus mainly on this part. Okay, we are mainly going to focus on the optical communication channel. Communication channel means the medium through which the signal is transmitted. This is our main part. Okay, so this is the block diagram. But there is a two type of communication. One is a guided communications. Guided communication means we want to secretly send the information to somebody. Suppose you just give a phone call, and we just want to discuss some specific secret discussion. Then it is not open to anybody else. Nobody can share this information. So this is called guided communication. Unguided communication means, and it is this optical communication mainly used in telecommunication. And unguided communication means the information source is send the signal to the transmitter. Okay, transmitter will send the signal everywhere in the space. Suppose and the radar communication, space communication is an unguided communication. But here with a telephonic discussion, telecommunication is a secret conversation. It must be guided communication. Okay, there is a two type of communication. One is a guided communication, one is unguided communication. But here we are mainly focused on the guided communication. Number one. Number two, we are mainly focused on cable, coaxial cable communication, and optical fiber communication. So, okay, guided optical fiber communication or coaxial cable communication. Both are electromagnetic, sending information from using electromagnetic carrier. Okay, carrier means I am a person. Suppose you give me some specific item to your parents. I take from you and give to your parents. So I will back to my home. I am carrier. But information is whatever you have given to me, and I have already delivered to your family. That is information. I am the carrier. Okay, in optical communication and electromagnetic communication, whatever coaxial communication, the signal is an electromagnetic wave, and it is mixed with the original input signal and sent through the pipeline. Suppose I am giving another example. No need to, you have already understood. Okay, so these two communication, coaxial cable communication, suppose copper wire communication, okay, and optical fiber optics communication. There's a two vast difference. Optical communication, there's a loss of information during sending from information source to transmission source is very, very less as compared to coaxial communication. Number one. Number two, optical frequency range around 200 terahertz. Okay, but in coaxial communication is operating frequency, carrier frequency around 20 gigahertz approximately. This is very high because of high communication carrier in optical medium. Optical medium is a high operating carrier frequency, that is approximately 200 terahertz, and coaxial communication operating frequency up to approximately 20 gigahertz. So that is why this optical communication can carry more information as compared to the coaxial communication, apart from the loss. That is another advantage. Number two, in coaxial communication also send the electromagnetic carrier, also use electromagnetic carrier, which is mixed with the original signal. The loss parameter is significantly high, and which is measured in terms of signal to noise ratio. It's very high as compared to the optical fiber optic communication. That is in the context of loss analysis. Number three, the security purpose. The in coaxial cable connection. Simple example. Suppose this is a coaxial cable. Okay, coaxial cable. The information will like this. Some information will loss coming out from the coaxial cable. So there is a probability of loss is very high. So if the loss is very high, it will come from the coaxial cable. If somehow information is leaked out, then what happens? The security is less as compared to optical fiber. But in optical fiber, fiber is very, very thin, low diameter. It's just like a single hair. This single hair means it composed of 100 fibers. Okay, 100 more than 100. So in that case, security of the loss of radiation during the transmission from one point to another insignificant, and therefore security is high security in optical fiber optic communication. But both are used telecommunication. Nowadays everywhere use optical fiber optic communication because of high security, high speed. That's what I have already told, 20 terahertz operating frequency. So that means more information can send within a second. High bit rate. So that is why first we are focusing on our optical communication. Channel is optical medium, fiber optics cable. Then we also discuss the coaxial cable. Okay. Now, now basic understanding. Okay. Now, theory. One ray theory. Two, EM theory. See, in order to understand communication, we have to understand two theory. One is a ray theory. Ray theory means geometrical wave. Geometrical wave means that is a focal point, focus point. That's why we have already studied in ACES. That is geometrical expression. We draw a diagram. This is I. This is focus is here. Focus is here. That's this type of diagram we have studied in ACES. This is known as the geometrical optics. This is not wave optics. Okay. And this is a ray theory. Okay. So, in order to understand the optical communication, we have to understand the two theory. One is a ray theory, which is also known as the geometrical optics. That's what we have already studied in ACES second year. Okay. Next was the electromagnetic theory that is related to the wave properties. Electromagnetic wave. Okay. Dual aspect of radiation. That's what you have already studied in ACES2. Around chapter number 13. Okay. But ray theory we are using an initial understanding of optical mechanism and measurement of some specific parameter. I'm telling you, this ray theory is used here only to understand the basic parameter. Again, I'm telling, understanding of optical communication through optical fiber is required to understand some specific parameter at the initial point. For example, numerical aperture, refractive index, cutoff frequency. In order to understand this type of 1 or 2, 3 basic parameter which are necessary to understand optical communication, we will use ray theory, okay, geometrical optics. After that, inside what happened after sending the signal from inside the cable. See, this is a cable. Again, I'm telling, this is a cable, optical fiber cable. Okay, this is axis. This signal means this is geometrical optics we are using. Okay, this is using, suppose the electromagnetic radiation. The total internal reflection inside that cable takes place. Now, geometrical theory is applicable only this initial part. It's just starting the interference. Okay, and this geometrical optics or ray optics is used to understand basic parameter, for example, numerical aperture, refractive index, cutoff frequency of signal, okay, and acceptance angle. This type of basic parameter necessary for communication system can be easily understood with the help of ray theory. Okay. However, nonetheless, this ray theory cannot explain the internal mechanism. Internal mechanism means how the signal, optical signal or electromagnetic radiation is transmitted through the fiber optics cable cannot explain by ray theory. Number one. Okay. This incomplete behavior of electromagnetic spectrum, electromagnetic wave inside the cable can easily understand with the help of electromagnetic theory. Okay. So that means electromagnetic theory, that whatever we have studied in electromagnetic wave in electromagnetic course, that Maxwell equation, wave equation in medium, wave equation in free space, that theory will give you a waveguide transmission line this theory, this electromagnetic theory will give a complete picture of electromagnetic behavior inside the cable. Okay, and of course it can also say detail about the electromagnetic behavior after coming up from fiber optics cable. Okay, but this real theory is used only to basic understanding of some passive parameter. Again, that's what I'm telling. Now I'm going to focus on the ray theory and the parameter associated with the ray theory. Why this ray theory used? Okay, and what are the parameters that we can easily understand with the help of ray theory? That's what we are going to discuss. First, we are going to do ray theory. Okay, ray theory. I'm starting the ray theory. I hope you can understand. If you have any doubt, you can send me SMS ray theory. So, before going to start the ray theory, I want to give you some basic idea about the refractive index. Most of the students, what actually refractive index define? This is the velocity of light in free space. This is the velocity in medium. In medium, it is free space. So, this effective understanding of refractive index is very essential before starting the ray theory. What do we mean by refractive index? Refractive index is a dimensionless parameter because C by V, the meter per second divided by meter per second, so cancel out. It is a dimensionless parameter, but it will measure. So, one example you can understand. One refractive index C by V, V1 equal to 1.5. Okay, suppose glass. And another refractive index C by V2, 1. What you can understand? So you don't know this part and this part. One effective index 1.5, one effective index 1. That means this is C is an in numerator, C is a constant. It is a 3 into 10 by 8 meter per second. And here C is also constant. So 1.5 means V is less as V2. What you can understand, V1 is less than V2. Okay, that means refractive index 1.5 means denominator must be less. Okay, as compared to V2, it is 1. So higher refractive index means what? Higher refractive index. This is higher refractive index. Velocity is less. And lower refractive index means velocity of electromagnetic radiation. Suppose this is medium A, refractive index N1, it is value 1.5. This is medium B, refractive index N2, and it is value 1. Now this effect 1.5 means this one 1.5 means V1 must be less than V2. Clear? Okay, that means what? Here effective index less, means velocity of electromagnetic radiation in matter B medium must be greater than A medium. So high refractive index means lower velocity of electromagnetic radiation in that medium. And low refractive index means the high velocity of electromagnetic radiation in that medium. So what you can understand, refractive index is a dimensionless parameter that measures how fast it can move, how fast electromagnetic radiation can move toward that medium. Clear? It is known as the refractive index. So refractive index means it is a measure, is a dimensionless parameter that measures how fast electromagnetic radiation moves in that medium. Higher refractive index means the lower velocity of electromagnetic radiation in that medium. And lower refractive index means high velocity of electromagnetic radiation in that medium. Clear? This is known as the refractive index. So why it is essential? Why it is essential? That's what I am going to tell you. Because the ray theory explains the total internal reflection. So most important requirement in optical communication, the total internal reflection must take place inside the cable. Why? That is why I am telling you. ray theory will explain the behavior of this is suppose medium 2, this is refractive index, medium 1, suppose this is 1, this is effective medium 2, this incident light, this is reflected, and there is little bit reflection take place. We'll forget about this part right now. Okay, this is incident light and this is incident angle, this is a refracted angle. Now what happened? Suppose this is glass 1.5 refractive index, it is 1 air. So whenever electromagnetic radiation from higher effective index medium, higher dense medium to move to the lower dense medium, then ray is deviated away from normal. It is a general max. But when you increase the second case, you see this is a normal, okay, this is a normal. Second, if we increase the incident radiation beyond this value, then what happens? It will move toward the horizontal line. Finally, it will move this line. This is a refracted angle, okay, this is the incident. So what you can understand, if we increase the incident radiation in denser medium, suppose for example glass, okay, then the transmitted radiation move horizontally. After specific angle, suppose if we increase more the incident angle, this is the third case, third diagram, if we increase the, this is a normal, if we increase the incident radiation more, then total internal reflection take place. Theta and theta. Okay. This previous example, I draw it again. This is a theta incident critical, and then it is a ray move to the normal. This is the angle. This is known as the theta critical C. Critical angle is the incident angle in denser medium for which the refracted ray moves horizontally. Okay, and if we increase the incident radiation, incident angle greater than critical angle, that happen. So it will move to that medium. That means that after a particular angle of incident, the refracted light will not, this incident light will not pass through the medium to other medium. It will back to this medium. This is known as a total internal reflection. Why it is essential? See. And this is the first requirement in optical fiber optics communication. Optical fiber optics communication means total internal reflection must take place inside the cable. Okay, you can easily understand. This is a cable, channel, okay, optical cable, fiber cable. Okay, and this is a section of cable. Okay, you can easily understand. This is a cable. Okay, this is a cable and this is a cable, suppose. Inside there is a hole. And this is the optical, this is optical axis. This is optical axis. This is axis. Imaginary axis, coaxial axis. It is known coaxial axis. Now what happened? See, this is known cladding. Refractive index N1, N2. Suppose in air, suppose it is air, for a previous example, less effective. And this is known as a core, N1. N1 is greater than N2. Clear? Now what do you see? Suppose if I send an electromagnetic wave, it will fall here and fall here at this point. This is again this is called total internal. This is a denser medium. Inside is a high refractive index N1. N1 is greater than N2. So it will not fall here and total internal reflection take place. Again it will come back. Again it will move. Here again total internal reflection take place. It will come back. Again it will come this point. This is denser medium. This is rare medium. So a high refractive index move to the lower refractive index is a total internal reflection take place. As a result, electromagnetic radiation is confined within the coaxial wire. Okay, this core, and it will move to the inside the cable. So there will be no loss. Okay, and that is why total internal reflection is essential for optical fiber communication. Number one requirement. Number two requirement. How will I send? You see, this is inner part is okay. Total internal reflection is clear. We understand. This is okay. Now my second question is that at this specific angle, if you send this angle, if you put a torchlight, then electromagnetic wave it will move directly. Then there will be no total internal reflection. That means you have to send the information. That's what I am told you. That is optical source, then channel. I have told you channel. This is known as a channel. Okay. This is come from optical source. Okay. Now optical source, we have to send the optical signal, light suppose, at a specific angle, so that it will fall here and back to moves to here and here and here. That means so that the light internal reflection take place inside the cable. That means we have to send the optical signal from optical source to the cable in such a way that the total internal reflection take place optical fiber. And that is why we put a optical optocoupler. So that means there we have to measure the specific angle at which optical source must follow the coaxial cable. So the total internal, this is known as the acceptance angle. I will discuss here. Okay. This is the internal mechanism. Now what happened? So if we see this diagram, if we forget about this diagram, this is a core cladding, internal reflection take place. Then what happened? From Snell law, this is for calculation. Okay, from Snell law, we know sin theta 1, sin theta 2, theta 1 is a theta 2. You have already told. Sin theta 1 and theta 2. Theta 1 and theta 2, we know the refractive index n1 by n. Clear? This is from Snell law. Theta 1 and theta 1 and theta 2. Now theta 1 is suppose a critical angle, but incident angle is theta 1. Theta 1 critical angle. At critical, if sin theta, suppose here you can easily understand. Suppose this is the incident angle, theta 1. Okay, and this is moved like that. This is theta 2. Clear? And this is medium refractive index. This is medium 2. If sin theta 1 incident angle become a critical angle, sin theta c critical angle t, then sin theta 2 is 90 degree. So it will be 1. So is equal to n1 by n2. Oh, sorry, it is reverse, n2 by n1. So it is n2 by n1. And this is this refractive index. That means critical angle. This formula why I am giving here. Using this formula, you can measure the critical angle. Measurement of critical angle is very essential. That means be greater than critical angle, you must follow the electromagnetic radiation inside the cable. Then total internal reflection takes place. That is why understanding and measurement of critical angle is very essential. Okay. So this is how we can measure the critical angle. So ray theory, what we can measure? Critical angle we can measure. Numerical aperture, I am going to do that. So, and then I am drawing a better diagram. You can show that you can understand better diagram inside the cable. What happened? So, graphically, I want to give you the basic idea. This is a section of cable, okay, and this is inner side, okay, inner side. This is the inner side. This is coaxial axis. Coaxial axis. So so ray from this side and this side. Suppose ray coming from here. Okay, ray coming from here moves to here. This N2 cladding and this effective index N1. N1 is greater than N2. It means this is a denser medium, this is rare. Then it is happen, it moves to this. This is not dotted line, this is. Okay, this is theta 1, this is theta. If denser medium, this theta is greater than theta, say critical angle. Okay, then again there is a total internal reflection take place. This is theta and this is theta or equal pi, and this is again here move. This is total internal reflection, and this is how electromagnetic wave sending. Okay. This is how internal reflection takes place inside cable. I hope you understand. I am not removing the diagram. Okay, I am putting all diagram here. I am removing this part so that it is not confused. Now you hope you understand. This inner side is this I am drawing here, and this is one cable. Okay, coaxial cable. That's the inner part is core and outside is cladding, and inner side has a high effective index. Why? Because internal reflection takes place from denser medium, in between denser and closer. This is rare medium, this is denser medium. This is optical axis. Okay. Now what happened? I am removing this part again, so that you can understand the diagram. And this I am putting here. This is this part, and this is optical axis. This is diagram. This is coaxial axis. This is axis, RBT line. Okay. Now you see specific angle. I am sending here. I am sending here. This ray will. This is total internal reflection take place here. Then it will move to here, like that. Total internal reflection. This is the internal reflection take place. Okay. Then I am sending another example. This is theta A. This is ray is represented as A ray, theta A ray, and this is represent. This is phi. This is phi and this is phi, same angle. Okay, this is O point or this is P point, and this is theta 2. This is theta 2. Okay, and another example like that take place, and this ray move to this side, also move to this side. This is another ray. Okay. This is known as a loss. What I want to tell you, that means at a specific angle of incidence from outside to inside optical fiber, at a specific angle, you have to allow to fall the optical signal or light to the fiber optics cable. Otherwise, suppose I am example theta B. theta B. This theta B, B line is another angle. This is theta B. What happened? A line is that we allow to fall electromagnetic radiation at a particular angle theta A, and this theta A fall at this point and moves to the inside the cable, and total internal reflection happen here and here. But another angle which is not equal to theta A, we allow to fall electromagnetic radiation, but at this point the ray moves to here. Some portion of light moves back toward the same medium, and some portion of light moves to the rear medium. As a result, this radiation will be lost. Okay, only the specific angle at which total internal reflection is take place is known as is allowed, and this angle theta A is known as a numeric acceptance angle. Acceptance angle means angle of incident coming from a basic medium toward the cable at which total internal reflection takes place inside the optical fiber. Okay, this is called acceptance angle. This acceptance angle is measurement of acceptance angle. I can easily tell you. So, core cladding interface. This is core cladding. Okay, core cladding interference. This is suppose refractive index N0. Okay, N0 is suppose air. This is N0 refractive index. Then this is N2. Okay, N1. N1 means core, and then this is N2. Now I am focusing on interference part. Interference part means, I think core cladding, core, air and core. Air, this is air, this is core. Refractive index N0 and N1. We are measuring the calculation. So what happened? N0 sin theta A means incident angle. This angle theta A means theta 1 means theta A equal to N1 sin theta 2. Okay. Now we get theta 2. If you see this angle, this is a right angle angle. So theta plus phi equal to 90 degree. Is it okay? Theta 2 plus phi equal to pi by 2. What is the value of theta? Theta 2 equal to pi by 2 minus phi. So I can write N0 sin theta A equal to N1 sin theta pi by 2 minus phi means cos phi. Cos phi means you can represent N1 under root of 1 minus sin square phi. Okay. So I erase this part. I hope you understand this part. So N0 sin theta A is equal to N1 under root of 1 minus sin square phi. So sin square phi, if you put this value, what is the sin square phi? I have already derived. Sin square phi is the angle. I have derived this formula. Sin theta C is theta 1. Theta equal to sin theta C, I have equal to N2 by N. You have phi means what? Here phi means, here see, this one is phi, this one is also phi. So it will be sin phi equal to N2 by N1. Okay, if you put this value, then you will get under root of, I have already given you this formula, this one. Okay. This is measurement of numerical. Now N0 sin theta A, okay, equal to N1 minus N2. This is the general formula. Now this electromagnetic ray coming from air to core, okay, dancing medium. N0 is, if we consider the air, N0 is equal to 1. So numerical sin theta A equal to N1 minus N2. This is the general expression of numerical aperture. Acceptance angle. So acceptance angle is a sine angle at which we can allow to fall the electromagnetic radiation from optical source toward the fiber inside the fiber of the cable, so the total internal reflection take place inside the cable. Okay, this is called numerical aperture of the fiber. And this is theta I is a acceptance angle, and this is known as a numerical aperture. Numerical aperture is this parameter, n not sin theta A. For air, n not equal to 1, that's why I am writing sin theta A. Okay, this is known as a numerical aperture. And theta A is the acceptance angle. What is acceptance angle? I hope you can easily understand. Acceptance angle is the angle at which if electromagnetic light fall on an interference, then total internal reflection take place. At which total internal reflection take place inside the cable, that angle is known as the acceptance angle, and product of refractive index of that medium with sin theta, sine of that acceptance angle, is called as a numerical aperture. This basic understanding, numerical aperture and acceptance angle, critical angle, phenomenon of total internal reflection, this you can understand using ray theory. Beyond that, inside the cable, how electromagnetic wave propagated from source to destiny inside the cable, you cannot explain the ray theory. Okay, and that part you have to if you want to understand that part, you have to understand the electromagnetic wave, and solution of the electromagnetic wave inside the cable is very essential. That's why in the second class I am going to tell you the wave equation, solution, what is the meaning of solution, what is monochromatic radiation, what is a polarized light. I will tell you in detail. Then you can understand the rest of the part. That part will come on to the electromagnetic wave part. So you have to give better focus here. Then no need to study that part, electromagnetic wave. Same part I am teaching here and there, common part. Okay. Thank you.